Lesson 118 of Saxon Math Course 3 is about sine, cosine, and tangent, which are all measurements that are used in a branch of mathematics called trigonometry. Now, when we're going into trigonometry, you may have heard that phrase before. It's the process of doing math involving the angles of triangles. Now, as we're solving these problems out, you may see things similar to them in the future, and you will see this phrase, SOHCAHTOA, throughout most of high school. This is a lesson that's going to stick with you throughout all of the math that you're going to take. And in fact, trigonometry is one of the most highly used branches of mathematics in construction, in animation, and in all sorts of things. So we're going to go into today's lesson about sine, cosine, and tangent. Now, we had a lesson before which talked about the relationships between the angles in a triangle and the sides of that triangle. Now, if you have a right triangle, we have special names for those relationships, and those names are sine, cosine, and tangent. There are a few more, but we're just going to focus on sine, cosine, and tangent today. Now, sine is the relationship of the opposite leg over the hypotenuse. Cosine is the relationship of the adjacent leg over the hypotenuse, and tangent is the ratio of the opposite leg over the adjacent leg. Now, most mathematicians and students use the mnemonic device SOHCAHTOA because it's a fun word to say and it helps us remember the order in which these things go. Now, you want to separate so, ka, and toa as they each break off into their own equation. Here we can see that so is how we remember that sine is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse, and tangent is equal to the opposite over the adjacent. So we can remember sine opposite hypotenuse with so, cosine adjacent hypotenuse, ka, tangent opposite adjacent, toa. So remember that it's the function, the numerator, then the denominator. Function, numerator, denominator. Function, numerator, denominator. The thing on the left, thing on the top, thing on the bottom. So, ka, toa. You should all say that at least 3 or 4 times. It's a fun word to say, and it's important that you remember it, because if you don't remember it, then you won't be able to apply it. Now, in example 1, we're asked to find sine, cosine, and tangent of angle A. We should remember we're going to be given an angle that we're looking from in order to find the opposite and the adjacent. The hypotenuse is going to stay the same the whole time. Now, sine, remember, is opposite, so opposite over hypotenuse. Now here, the opposite of A is 6. The hypotenuse from A is 10. And 6 over 10 is 0.6. Cosine, ka, cosine equals adjacent over hypotenuse. The adjacent in this problem, the side next to the angle A, is 8. And the hypotenuse across from the right angle is 10. 8 over 10 is 0.8. And the tangent is the opposite, toa, opposite over the adjacent. Now, the opposite is 6, the adjacent is 8, and 6/8 is 3/4, or 0.75. Now, our next example is example 2, and it says that we should find the sine, cosine, and tangent of angle R. Now, this one's a little bit tricky because we're not given any measurements on our triangle at first, but we are given the angle measurement of 30 and 90. Now, we can remember that if we have a 30 and a 90, the last angle has to be 60. So we can see that it's a 30, 60, 90 triangle. And a 30, 60, 90 triangle always has a leg of 1, a leg of root 3, and a leg of 2, or a hypotenuse of 2. So we can say that we have 1, root 3, and 2. Now, we want to label those as opposite, adjacent, and hypotenuse. The opposite from R is the side, which is 1. The adjacent to R is the root 3. And the hypotenuse is the 2. Now, sine, remember, is the so. Cosine is ka. Tangent is toa. So sine, opposite, hypotenuse. Sine, opposite, hypotenuse. The opposite was 1. The hypotenuse was 2. And 1/2 is 0.5. Cosine ka. Cosine, adjacent, hypotenuse. So we put adjacent over hypotenuse. And the adjacent was the square root of 3. And the hypotenuse was 2. Now, if you wanted to estimate that, you could plug that into a calculator and you would get about 0.866. Now, for tangent, tangent is toa, so we have our opposite over our adjacent. Now, our opposite is 1. Our adjacent is root 3. If we were to plug that into a calculator, the estimate that we would get back is 0.577. Now, a cool thing about sine, cosine, and tangent is if you're given an angle like 30, if you have a calculator that's a scientific calculator, you can actually plug in sine, which will be spelled S-I-N on your calculator. It'll come up with a parentheses, and you'll write in 30. And when you plug that in, you should get 0.5. And you can do that for cosine and tangent as well. Because these functions are always the same for this angle in a right triangle. Every opposite and adjacent, opposite and hypotenuse, adjacent and hypotenuse, will always simplify down to these things for a triangle with a 90 degree, a 30 degree, and a 60 degree from the perspective of the 30 degree. And that's pretty neat. Now, I hope you all stay safe, have some fun, and wash your hands.